Nice to see you here. My name is Patrycja Wegrzynowicz, and today I'm going to tell you about secure authentication and session management in Java EE. Briefly about myself, I've been doing professional software development for nearly 20 years. I've always been active developer, and I still am, and I must say I love it. Most recently I founded a company, Unita. In Unita, we aim to bridge a gap between the industry and the academia. We work on automated tools for detection and refactoring various security vulnerabilities, anti-patterns, like performance anti-patterns, database issues, concurrency issues. So basically, security vulnerabilities are my daily job. Remember my Twitter handle, which is YonLabs, because we'll use it heavily during the session. What am I gonna talk about today? First, a brief introduction to security problem, HTTP concept, and session. The key part of today's talk includes 4 demos that illustrate how to hijack a session. How to use XSS to steal the cookie, how you can use a session without users' knowledge and its permission via exploiting cross-site request forgery. Security vulnerabilities in recent years. For the last 2 decades, web technologies have experienced a significant growth. The number, the size, and the complexity of software have increased substantially. Unsurprisingly, many new technologies to attack IT applications have been developed as well. 2014 and 2015 show that pretty well. A lot of serious vulnerabilities have been discovered, like famous Heartbleed. How many of you have ever heard of Heartbleed? That's back in OpenSSL library. Not less famous, Shell Shock. How many of you have ever heard about Shell Shock? That's a vulnerability in Bash. And Logjam. Anyone have ever heard about Logjam? A few of you heard about that. So that's another vulnerability in TLS, which allows to downgrade the protocol, and in result it allows to get access to any transferred data. So there is no doubt that security is important in today's world. But let's get back to web. HTTP is the foundation of communication for the World Wide Web. It's a stateless application protocol based on a request-response communication schema. What does it mean it's stateless? It means that each request is processed independently. And as we think of web application, there is an obvious need for statefulness, right? We must keep track of the user authentication, we must keep track of user data, like what's in a shopping basket or what's not, right? So how can we achieve that? That's the place where session concept comes in handy. A web session identifies interactions with one user. The implementation is simple. We need to associate a unique identifier with every request sent from a single user. In Java, this identifier is named JSessionID and is implemented as a cookie or a URL parameter. Everything works great, right? So what's the problem? The problem's here. broken authentication and session management is number 2 on the list of top 10 security risks according to OWASP. OWASP stands for Open Web Application Security Project. It's a non-for-profit organization which aims to increase security awareness among developers. Every 2 or 3 years, OWASP publishes the list of top 10 security vulnerabilities in web application. And it turns out that authentication and session management cause a lot of troubles to software developers. The problem is that we, as software developers, rely on the platform, right? So I remember my own experience from 10 or 15 years ago when security officers asked me about the security and wanted to audit my application. My answer was, what are you talking about? I'm using Java EE. That's what I need, and the platform works great and it does everything for me. And unfortunately, that's not the case. We, as developers, often rely on a session ID as a single mean to identify the user, and we don't protect the session ID carefully enough. So all this means that our sessions are very easy targets for hijacking. There are 3 primary types of session attacks. The first one is to steal the user's session. The theft can be done by various means, like a session ID can be exposed in URL. We can sniff a session ID, monitoring network traffic. We can use XSS and some other techniques to steal a session ID. The second type of session attack is to fix a session ID and to trick a user to log in with our fixed session ID. And the third one is to guess the session ID. In cases where the algorithm to generate session IDs is not strong enough. And the last one is the least likely in the Java world, but still it can happen. Anyone here have ever used Jetty as an application server? Okay, so the old versions of Jetty were vulnerable to this kind of session prediction. They had like a very weak session generation algorithm. So it's time for the first demo. I will log into my sample application. I will post a link on a Twitter, and then you will hijack my session. Okay. So this is a sample application. Only I know my password, but you can get access to my secrets if you hijack my session, right? So as you can see, session ID is exposed in URL, and I will post this URL onto my Twitter account. And this way you will get access to my session and my secrets as well. Do you have access to the internet? So check out my Twitter account. It's Sion Labs. You will get access to the link I've just posted. And then you can get access to my secrets. So you see that there are already 3 hackers. You are pretty fast. And take a look at IPs and agents, browsers they are using. So we have different IPs. Do you use your cell network or do you use the conference network Wi-Fi? I've been using my conference Wi-Fi, so I guess that the last one is my IP. This is Mozilla Firefox user agent, and we have iPhone and iPhone devices. Okay, so most of you are using iPhones. Okay, and we have much more here. So you've seen how easy it was. So congratulations on your first hijacking attempt. So what was the main problem of the demo? The problem was that the session ID was exposed in URL. Think of all those public places you serve the internet in, like coffee shops, like lectures, like conferences. Imagine how easy it's to take a photo of your laptop, of your screen, or of your cell phone. And you've just seen that it's even easier to use the captured session ID later on. So the default behavior of Java web application is that it allows cookies as well as URL rewriting. So session ID in URL. Cookies are the first choice, but an application falls back to URL rewriting in case when cookies are disabled in a browser. There are two options to disable URL rewriting. You can disable URL rewriting in an app server, and this is an app server specific option. Or we can use a tracking mode, the configuration parameter in web.xml. So by setting tracking mode in session config in web.xml to cookie, we disable URL rewriting. This parameter is available since Java EE 6 and Servlet 3.0. Even if we disable URL rewriting, hackers can still eavesdrop users' session IDs. However, now they need to put much more effort into it. For example, they can use network monitoring and packet sniffing tools. Once they find out session ID, they can use it as a cookie. They can use a plugin or add-on for a browser, like Cookie Manager for Firefox. They can use proxy, like OWASP set application proxy. Finally, they can write their own code to connect the application in question and make use of a stolen cookie. So it's time for another demo. You've already hijacked my session. Now it's time for me to hijack one of yours. I will use two tools, TCP dump for network monitoring and Cookie Manager or OWASP set application proxy to intercept HTTP requests and set up the cookie. The application is almost the same as the last one. I've only changed the tracking mode to cookie and the authentication realm that now you can log in with any non-empty username and non-empty password. Oops. Okay. Wait a moment, and okay, so now we have session cookie. I will post, wait a moment. First I will run TCP dump. I will log in to my server and run TCP dump. Now there is no traffic, so nothing seen. When you will be connecting to my application, then we will see a dump of each HTTP request. Oh, we see here something. So probably some of you refreshed or accessed once again the previous page. Okay, so now I will send another link for you. And please use meaningful names so we will find out which sessions I've managed to hijack. Okay, so just access the new link, log in with your name and a non-empty password. And I will see the dump of the traffic, and I will pick up one of the session IDs to hijack. Okay, so we have the first one. This is the session ID. First, I will use simply. Okay, so you see that I've just logged in as Patrycja. But now I will use Cookie Manager to change the cookie. Okay, I'm changing into the new one. Saving, and now I refresh the page. So, Kara Murad, who's been that? Okay, congratulations, I've just hijacked your session. So you see that that's really very easy. I've used here Cookie Manager. Now I will use, I will hijack one session more, and I will use OWASP Z application proxy to intercept HTTP requests. So first I need to configure HTTP proxy in my Firefox browser. So OWASP ZAP proxy is already running. I've configured the breakpoint for yonita.com. So every request going to yonita.com will be intercepted, and I will be able to take a look at HTTP headers and body. Now I need to configure that in Firefox. Okay, so that's the configuration for Firefox. And I will use, okay, so now you see the HTTP request has been intercepted. Now I'm able to modify and set up new session ID. Okay, I will use one. Oops, the problem with the proxy is that it blocks other applications. So I think that first I will copy one of the session IDs, and then I will intercept. Okay, so changing the preferences once again to no proxy, switching to TCP dump. I'm trying to find another session ID. Okay, there are a lot of other requests as well. Okay, this one. We'll see how it works. Okay, so once again switching to the proxy. The breakpoint is configured. Okay. I'm logged in as Patrycja, and I'm refreshing the page and changing J session ID to the one which I copied. Okay, so now it's Voxed. Who was that? Tell me. Anyone here? Okay, we got you. So thank you for your cooperation. You've seen two of your sessions being hijacked. That was a piece of cake, right? And now we'll learn how to counter such attacks. The answer is simple. The question is how to avoid session exposure during transport. What is your idea? Do you have any? Yes, exactly. Elementary, my dear Watson. Use HTTPS, right? And use it properly. Remember about Heartbleed or Logjam. So you need to configure your web server properly with proper OpenSSL version and to avoid Diffie-Hellman key exchange during transport. And what about Java EE applications? How to configure secure transport in Java EE? First of all, in web.xml, we set up a security constraint to use a transport guarantee set to confidential. And then also in web.xml, we configure the secure flag for cookies. It prohibits browser from sending cookies over unencrypted channels. We guarantee that cookies will be sent only over HTTPS. This configuration parameter has been introduced in Java EE6. In previous versions, to configure that, we had to use a custom interceptor to add this flag to a cookie. This is very important because otherwise, for example, if you serve static resources from the same domain context as your dynamic application, dynamic content, your cookies, user cookies, will be sent over unencrypted channels. For example, when they access static resources, because static resources usually are served from HTTP just to avoid additional performance overhead, right? So this configuration is very important and usually is missed by Java developers. So far we've made sure that our session ID won't leak during transport. But there are two other places our session ID can be exposed. The client side and the server side. On the client side, the typical attack to steal a session ID involves XSS, cross-site scripting. But also beware of malware, which is spread via email, exploit browsers, or OS vulnerabilities. If it can access your browser data, it means it can steal your session IDs as well. Usually we don't care so much about the server side. But remember that many attacks are performed by the insiders. So don't store user session IDs in your logs. Think of secure channels for session replication in your server clusters and so on. By the way, any of you use application server cluster in production with session replication? Anyone? So lucky you, you don't have that problem. But there are still deployments in production which use session replication and application server cluster. So now we have secured the transport. It's not that easy to steal a session when HTTPS is used, unless you have unpatched OpenSSL, Heartbleed, and unless you are using Diffie-Hellman key exchange for TLS protocol. So how can we steal a session if secure transport is used? client is usually a soft spot, so we'll attack client and we'll use cross-site scripting to steal a session. So to steal a session via cross-site scripting, we need 3 pieces of code working together. The first one is a JavaScript code to steal a cookie. The second one is a servlet or any other dynamic application that logs down stolen cookies. That's on the hacker side. And the last but not least, there is a vulnerable application needed that will be exploited via injected JavaScript code. So the third demo, I will store malicious JavaScript code in the application to writing opinion. And you will log into the application and you will see others' opinion, and this way I will steal your cookie once again. So another demo. Oops. Okay. Okay. I should update. No, it's a problem with the proxy. Okay, I need to turn off the proxy because otherwise, when connecting through proxy, SSL certificates are not verified properly. Okay, so that's the problem. So wait a moment. I will turn off the proxy. And now we have another application. I'm logging in as Patrycja, and I'm sharing my opinion about Vox Day Istanbul. This is an awesome conference, but I will add some additional code to that. This is my JavaScript code to steal the cookie. You see that I'm accessing in JavaScript, I just access document.cookie. So this is a cookie, a session ID value. And I'm sending it to my URL. And I will use image source to load this URL. This is just to bypass the same origin policy implemented in the browsers. Okay, so I'm adding my opinion. If you see the page with others' opinion, you will see Patrycja, this is an awesome conference. You will see only that. The JavaScript is in the page source and is interpreted by a browser as an ordinary JavaScript code, right? So now it's your time to access the application and see the opinions and share your opinion as well. Okay. Demo 3, and I'm waiting for your cookies. So just log in, share your opinion, and see others' opinions. And in the meantime, I will observe the logs on my server, where the stolen cookies are written down. Okay, waiting for you. And then again, I will use a cookie manager just to replace my cookie with one of yours and see whose cookie has been stolen. Okay, can you access the page? Okay, I see more cookies coming in. So now it's time to see whose cookies has been stolen. Just replacing my cookie with one of yours, and it's been Volkan. Where is Volkan? Okay, lucky you. Okay, so what happened here? You see that I've injected JavaScript code. The application is vulnerable because it doesn't validate input, nor it doesn't escape the output. So this way, when we are going to view others' opinion and take a look at the page source, you are seeing script as it is. So HTML is with injected script code. Thus, the browser interprets the code and it executes it. So that's why when you access this web page, this JavaScript code has been executed and the cookie has been sent to my server. To my server, to my application just logs down the cookies, and then I can make use of them. So now it's time to learn how to counter this type of attacks, basically focusing on session management, because how to counter cross-site scripting, I guess many of you are aware of that. Okay, so once again, the JavaScript code to steal a cookie. This is a pretty simple piece of code. We need to access. Oh, this is. There is not document.cookie here, but you've seen that in my IDE. The tricky part here is that new image and image source set to our link. The problem here is that browser policy prohibits connecting to other domains than the web page has been loaded. So there are two exceptions for script codes and for images. So we are making use of one of those exceptions, images, and we are loading we are connecting to our link through an image. And how can we counter this type of attack? We focus here only on the session side. To protect ourselves against cross-site scripting in a more general way, we need to validate input and to escape output. But in case of web.xml and session config, we need to pay attention to one parameter, HTTP only, to set it to true. The default is false. What does it mean setting that to true? It means that JavaScript code won't be allowed to access our cookies. So document.cookie will return an empty string or null. The funny thing about that parameter is that it's not part of standard. So its implementation is browser dependent. And the funny thing actually is that the first browser which implemented and proposed this flag, it was Internet Explorer. which is famous of being the least secure browser, right? So, and after they implemented and proposed that, other browsers, other major browsers have adopted this parameter as well. On the other hand, it's not part of the HTTP standard, so we can't guarantee that all browsers implement this flag. However, as I said, most major browsers implement this flag, so in setting this HTTP-only flag to true, we are minimizing the attack surface for the hackers. And how many of you use JSF as your... okay, many of you. Are you aware about the difference between JSP and facelet when it comes to outputting parameters via dollar, curly brackets annotation? Notation. Okay, I will show you the code, because that's another interesting part, how you can shoot yourself in the foot not knowing the exact semantics of the underlying framework. Okay. Take a look at this JSP code and how our opinions are printed out to the page. This is simply dollar curly bracket notation, right? This is JSP, and this means that the output is not escaped for special characters. So that's why you've seen direct script tags being in web page source. That's a vulnerable application. Almost the same code, also the same annotation, but facelet works properly. So it escapes the special characters, thus XSS is not possible in our case. So such a simple difference and subtle nuance and a huge impact on semantics and how secure your application is. So basically, when you are using JSF and facelet, you are on the safe side when it comes to typical XSS. Another type of attack is session fixation. I've briefly described it before. Basically, imagine that the hacker opens a web page of a system in a browser. This is like a public computer, a coffee shop or a computer which is used by many users. So a hacker has access to this computer, opens a browser, opens a web page to a vulnerable system or system under attack. And this is the moment when a new session ID is initialized, right? The first time we connect to an application, usually the application on the server side generates and assigns session ID. Hacker has access to the browser, so he can take a look at the cookies stored in the browser, so he can write down session ID, and then he just leaves the browser, waiting for another user, for a victim, actually. So another user comes in, sees open browser, sees open page, he just logs in, and usually the application doesn't change the session ID, right? We just use the session ID previously assigned to this computer and open browser and open web page. So that's the moment when a hacker can make use of a written down session ID, and he can hijack user's session. So this is session fixation attack. What's the solution to this type of attack? Change the session ID after successful login, and more generally after every escalation of privileges. In Java EE 7, you can make use of change session ID method of HTTP servlet request. In Java EE 6 and before, you need to use a pair of methods, like you need to first invalidate the session and then request a new session. Best practices in secure session management. First of all, random unpredictable session IDs. This does not depend on you. This is application server specific feature. So but pay attention which application server you use and what type of session IDs application servers generate. So it must be at least 16 characters in length, random and unpredictable. You need to pay a lot of attention to secure transport and storage of session IDs. So cookies are preferred over URL rewriting. Use two cookies flags like secure and HTTP only. Use HTTPS consistently. Don't expose or don't serve your application from static and dynamic contexts. Don't mix those contexts, because otherwise hackers can make use of that and can exploit the feature of a browser which send cookies over to the same domain name over unencrypted channels. Don't use too broad cookie paths. So these are basic practices for secure session management. In case of session creation and destruction, use always new session ID after successful login. Remember about log out button, and set up your session length to 2 or 5 minutes for critical application and 15 to 30 minutes for the average application, just to minimize the time the hackers can access and exploit and hijack user's session. Session associated with the headers of the first request. Use sort of fingerprinting, because what was the main problem of my session hijacking? The problem was that the server side couldn't verify whether the request comes from the same source as the original one. We can, so even though I connected from a different computer than yours, I had a different IP, different user agent, still this application and the application servers do not check that. So we need to take care of that myself. So the typical technique is to fingerprint the first request. So we create sort of a fingerprint from different headers, like user agent and IP. And with every subsequent request, we check whether this match our original fingerprint. Oops. If it doesn't match, it means that something wrong, and for the server side, it's better to invalidate a session. In case of secure authentication for Java EE, declarative authentication implemented using annotation or descriptors does not force new session ID after login. So you need a programmatic authentication to implement that. And here Java EE 7 comes in handy with its authenticate, login, and logout method. So my choice for secure authentication would be programmatic authentication, but declarative authorization. And it's time for the last demo. So what if we can't steal a cookie? We've turned on the HTTP only flag, so our HSS cross-site scripting vulnerability can't be exposed and exploited so easily. So what can we do when we can't steal a cookie? We can still use it. We will exploit cross-site request forgery vulnerability that makes use of a browser feature related to cookie management. If a browser has a cookie for a given domain name, it will send this cookie with every request to this domain name, even the requests made from a different tab or a different window of a browser. So now, the last demo of today's session, I will log into the application. Then I will give you a link for you to log in, and I will provide you with a link to an unsuspicious page, which will make use of a cross-site request forgery vulnerability. Okay, basically the last application is a simple banking application, sort of. So I have my account balance set to 1,000 lira. Is that a lot of money or so? It's, I suppose that's a good enough amount. Okay, so I'm logged in. Now it's your turn to log in. The last demo. And okay, I will close unused pages. Okay, this is my page, and this is unsuspicious page with one click me button. Okay, are you logged in and ready for another link? Okay, so I'm sending the last link of today's session. And I'm observing carefully my account. Nothing here. Please click the link and click the button. Click me. The last link and click me button. Okay, we have the first victim. Alishan. I'm sure that's incorrect pronunciation. Who was that? Okay, congratulations, you are the first to help me increase my account balance. What happened here? If you take a look at the page source, you will see that there is a form here, a hidden form with hidden values. Basically, this is exactly the same form which is used in the original application, but it has some inputs set to predefined values, like amount to 666 and to my name, right? Take a look here. To parameter is set to Patrycja and amount is fixed to 666. So when you are clicking click me, you are sending this, this form to the server with your cookie ID. That's the default behavior of a browser. That's why even though you open this page in a different browser, the browser still uses your logged in session ID. And that's why your account balance has decreased and my account balance has increased. How can you avoid that? Any ideas? Do you know how to protect against such types of attack? Yes, exactly. You are a very smart audience. So basically, yes, the solution is to use a unique token associated with each request. It's called anti-CSRF token. My piece of advice is for you is to remember also about not only about your web forms but also about your services. I mean REST services, because usually those services are not protected with anti-CSRF tokens, and they can be exploited exactly the same way. The configuration is web framework dependent. In JSF, by default, you have each form with anti-CSRF token included. In my application, I had to disable manually this token just to show you a vulnerable application. So the conclusion is you are never safe. Nobody's perfect. We all make mistakes. There is no system that guarantees complete safety to its user. So for sure, in every system you can find, or a hacker can find, some sort of a vulnerability. All we can do as developers, we can put more effort into securing our application. We can put more effort into educating ourselves. And it means learning, learning, learning. Basically, continuous learning paradigm. Thank you once again.